This is Learning Assessment Problem 8.8. In this problem, we will employ the problem-solving strategy of basic AC analysis with phasors and complex impedances. We are asked to find the time domain current I of t flowing from this voltage source. We have the time domain voltage V of t is equal to 120 sine 377 t plus 60 degrees. And we'd like to put that in the standard format of a cosine function, so this will equal 120 cosine 377 t minus 30 degrees volts, where there is a 90-degree shift between the sine function and the cosine function. So in the phasor domain, that voltage will be equal to 120 amplitude at an angle of minus 30 degrees. And again, the units are volts for that. Okay, the way we'll analyze the circuit is to consider the phasor current I that we're seeking. We'll have a current I1 flowing downward through this capacitor, and then another current I2 flowing downward through the resistor-inductor combination. We'll refer to the capacitor as an impedance Z1, and this series combination of the resistor and inductor, we'll call that Z2. We'll refer to the impedance of the capacitor as Z1 and the impedance of the series combination of resistor and inductor as Z2. By Kirchhoff's current law, we'll use the phasor domain and say that I is equal to I1 plus I2, and that would be summed at this top node in the circuit. And the expressions I1 will equal the voltage V, the applied voltage, divided by Z1, and likewise I2 will be the voltage V divided by Z2. Now we have to calculate these impedances. We have Z1 Now we have to calculate these impedances. Z1 is equal to ZC, the capacitive impedance, which is equal to 1 over omega C at an angle of minus 90 degrees. Z sub 1 is equal to 53.05 at an angle of minus 90 degrees. Z2 is equal to the combination of the resistance plus J omega L, the inductor. Z2 is equal to 20 plus J 377 times 0.04 Henry. Z2 is then equal to 20 plus J 15.08, and in the polar format this is equal to 25.048 at an angle of 37.016 degrees. And in the polar format, this is equal to 25.048 at an angle of 37.016 degrees ohms. Now we can proceed with the calculations of the current components. I1 is equal to the phasor voltage divided by Z1. This is equal to 120 at an angle of minus 30 degrees volts divided by that capacitive impedance of 53.05 at an angle of minus 90 degrees. And that is equal to 2.262 at an angle of plus 60 degrees amperes. Similarly, I2 is equal to V divided by Z2, and that's equal to 120 at an angle of minus 30 degrees volts, divided by our Z2 value of 25.048 at an angle of 37.016 degrees. And this equals 4.79 at an angle of minus 67.016 degrees amperes. Now we'll convert both of those currents to the rectangular format. We have I1 is equal to 1.131 plus J 1.959 amperes. I2 is equal to 1.8 I2 is equal to 1.870 minus J 4.410 amperes. And we add these two currents, and we have that the current flowing from the source, is equal to 3.001 minus J 2.451. Then we can recalculate this I in the polar form, and this is equal to 3.875 at an angle of minus 39.24 degrees amperes. And finally, we can do the inverse phasor transformation. I transforms to the time domain. I of t is equal to, recognize the amplitude, 3.875 cosine 377t, and then that phase angle minus 39.24 degrees amperes.